This simulation shows high-pressure fluid easily overwhelming a highly porous, traditional woven fabric. When dealing with severe arterial or venous hemorrhage, standard gauze simply cannot handle the fluid dynamics of the human circulatory system. To control severe bleeding rapidly, we use an advanced alternative, KytoStat, a highly engineered hemostatic dressing produced by Cottoncraft Private Limited. In this tutorial, we will walk through the exact steps required to deploy this dressing, achieve rapid hemostasis, and establish an antibacterial barrier over the wound. Possessing advanced medical tools is only the first step. You must know precisely how to deploy them within a critical window to stabilize the patient. Step 1 begins before you even touch the patient. You must inspect the sterile pouch for any punctures or damage. Because this dressing makes direct internal contact with the vascular system, applying a compromised seal risks introducing environmental pathogens straight into the bloodstream. Inside that sterile pouch is a dressing made from Chitosan. This natural biopolymer is engineered to chemically react the moment it makes contact with blood. This split-screen diagram highlights the difference. On the left, traditional dressings rely on the body's slow biological clotting chain reaction. On the right, KytoStat bypassed it by biological cascade entirely, relying instead on a direct, instant chemical adhesion process upon contact. Zooming in on the Chitosan action, we can see exactly how the fibers physically bind with the blood cells, rapidly expanding into a cohesive gel clot. Since it doesn't rely on natural platelets to initiate clotting, this physical adhesion process completes successfully even if the patient is actively taking anticoagulant medications. By relying on physical chemistry rather than biological cascades, KytoStat provides a consistent mechanism for hemostasis that does not depend on the patient's internal clotting chemistry. First, you must aggressively wipe away any pooled blood to locate the precise anatomical source of the hemorrhage. Once the source is located, do not simply lay the dressing over the surface. You must pack it deeply into the wound bed. Looking at this 2D cross-section of a deep, irregular wound cavity, you can see why. The vector arrows show that covering the surface leaves a deadly void. Packing forces the dressing all the way down to the vascular floor. For the chemical reaction to work, there is an absolute mechanical requirement. The Chitosan fibers must make direct physical contact with the actively bleeding vessel. The most common point of failure during application is superficially laying the dressing over a deep wound, entirely missing the bleeding source. The chemical reaction of the biopolymer is completely neutralized if you fail to execute precise mechanical packing. After the dressing is fully packed into the void, you must apply firm, continuous localized pressure directly over the wound using your body weight. This macro simulation shows the interior wound under compression. The loose microscopic fibers physically swell, tangle, and lock together, forming a solid, impenetrable gel seal. You must maintain this steady pressure for 3 to 5 minutes to ensure the chemical reaction fully completes. While acting as a plug, the resulting gel clot also serves a secondary function. It creates a robust antibacterial barrier that protects the open tissue from environmental pathogens. You will know the application is successful when external bleeding ceases entirely, and the visible portion of the dressing takes on a distinct gel-like texture. Sustained manual pressure acts as the essential catalyst, transforming the soft body